Very happy to be here today in JavaDay Lviv. My first time also in Lviv. I think it's always a little bit challenging to be on stage after Venkat. Feels a little bit like Rush being on stage after Kiss, but I will try my very best. I will talk to you today about integration testing for Java, and especially in the context with using Docker and test containers for better integration testing. Maybe a small, quick show of hands. Who of you has already heard of test containers, the test containers library? All right, quite a bit. And who of you is already actively using it? Okay, cool. So I hope maybe after the talk there will be more people using it, and wow, there it is again. So a little bit fragile connection here. Maybe I shouldn't move too much. Okay, a little bit about myself. First, my name is Kevin Wittek. I recently started to go back to academia. Now I'm a doctoral researcher. I'm doing my PhD at the Institute for Internet Security in Germany, and there I'm leading a blockchain research group. Before I didn't really have any blockchain background, but there are interesting computer science bits in there, and I try to really like this topic. But there will be no blockchain today here in this talk. And also I'm a self-employed consultant doing some trainings, workshops, and so on. But the main reason probably why I'm here is because I'm one of the test containers maintainer. We are 3 maintainers in total. I'm the 3rd of them. And yeah, also I'm a big fan of software crafting community. I'm one of the co-organizers of our local software crafting meetup in my home area. So, as a small motivation, I like to start with an anecdote I had in one of my former jobs that shows what could be and should be a motivation to do testing, to do maybe integration testing of your code. And back then, what happened is because maybe we as a team or in general didn't test enough our software, we as a team ended up here. We ended up on a farm with a lot of cows. So how did it come by? Back then I was working in a consulting company, and we were developing milking robots. And it had a Java server component that had the actual business logic, like how much milk to get from the cow, how much to feed the cow. Pretty interesting business domain actually. And it had a lot of business logic as kind of SQL queries basically. So the database was kind of important. And yeah, it was also already in production, so there was this milking robot, and it's kind of a cool system. So when the cow gets hungry, it goes into the cabin of the milking robot because it gets food there. Then while it gets the food, it gets automatically milked, all depending on like different calculations, business logic, and so on. But then one day we got a call from the farmer, and he said like, oh, somehow my like special food is empty all the time. What are you doing? Like the system is giving too much food to the cows. And yeah, we checked the logs, and indeed, like every time the cow was going in, it was getting like 3 kilo of this special protein power food or whatever, and that's not too healthy for the cow, although the cow liked it very much, and they were going in there like crazy, also giving a lot of milk, but still not economically sane. And we checked, started doing a bit more debugging, started a bit more checking, and oh no, yeah, okay, and then we found out actually there was kind of an off by 1 error in the calculation, like looking 1 day towards too far back, like thinking the cow hasn't been there for 1 day, kind of off by 1 error in the SQL query. Therefore the calculation said, okay, cow hasn't been in here for so long, let's give her like 25 kilograms. Luckily there were some safeguards in there, so they just got 3 kilograms, which is fine, I think, still not too good. And yeah, so we found this bug, fixed it, and then we had to update it. And for updating it, it's not connected to the internet, this farm and the servers. You have to go to the farm and update the server, which is standing next to the cows basically, so nearly in the cow shit, but just as nearly. Yeah, so and after this occasion, especially in this team, I also said like, come on, we have to do better testing, especially the integration testing, since this was an integration testing problem with the database, and I don't want to end up in the cow shack again. Yeah, so this really happened. I found it kind of funny, and what I want to show you today, how by using Docker and test containers, we are able to define and set up a complete test environment easily in code that allows us for an onboarding process of new developers, of new team members, to just basically check out the project, run the build with Gradle or Maven or whatever, and it should run everything. It should run, of course, the unit test, but it should also automatically run the integration tests, maybe even some end-to-end functional tests, and everything without following any like big wiki articles describing which database to install, how to configure the database, like those kind of articles when you join a new project that are always out of date, and you have to ask the other team members. They say, oh yeah, right, this article is out of date, but you have to do it, this, like spending the first 2 days in a new project setting it up. So I think we can do better as software developers in enterprise projects, but also in open source. It should be the same, like just check out the project and be able to build it. And if we are able to write integration tests in such a way that they are easier to write and execute, this might allow us to also shift a little bit the shape of our testing pyramid to maybe write more integration tests, if this is what we want. But maybe we don't want this. This might be up to you. So this is the classic software pyramid that came out of the agile testing movement, probably, as far as I know. And we see here we have a big foundation of automated unit tests. Then we have less integration tests. You can give them like distinct names, like separate them in a certain way. Again, say, okay, some are component tests, some are integration tests, API tests, black box API tests, whatever. But mostly we are referring to those middle layer as integration tests, I think. Then on top of it, often end-to-end tests, UI tests. Some people call them functional tests or acceptance tests. Yeah, let's call them a UI test somehow. And then what the actual testers in the teams should do is do manual session-based exploratory testing on top. So with all our automation, we can't get rid of this very valuable testing activity where we should have a good tester for this. Yeah. So, and yeah, we should strive to have this kind of pyramid, this kind of relations. In reality, they look often different. But maybe it also doesn't need to look like this nowadays anymore with new tooling we have, with new architectures we are developing. But first of all, let's maybe define how we define integration tests in the context of the talk today. And I would say the tests that interact with external systems or external dependencies. For example, if you have something like a Spring Boot test and it starts up the application context, like add Spring Boot test annotation. Some people would call this an unit test, but I would call this an annotation, an integration test, since we are interacting with the external system, with our framework that starts up this application server. But the classic example is, of course, when interacting with external ports, so outside world, things like the network, the file system, and database. Database, perfect example for integration tests. So, and yeah, so I said before, maybe we can rethink the pyramid shape, and some teams do it. For example, the Spotify team posted 2 years ago already a blog post describing their testing strategies, and they say their ideal test suite resembles this testing honeycomb. And here, like the bottom implementation detail is what we would consider a unit test. Then they have a big area of integration test, and then some integrated test. Does anyone know here what integrated test means and how we would define those? Yeah. So I will explain in a bit. It was also my first time I stumbled upon this concept in this blog post, but it's a really good way to think about a certain class of tests. I think it's very valuable, and to distinguish them from integration tests. So, but they say they have a lot of integration tests because they say they give them a better confidence. They allow for better replaceability of their microservices, so they have a very microservice-oriented architecture. Their microservices have like a comparably high integration service as opposed to their actual core implementation detail code. So they say, okay, it makes sense if our pyramid resembles this honeycomb, because also the microservice code resembles maybe this honeycomb, more integration surface as opposed to a monolith maybe. And to do these like good and stable integration tests, they are, for example, also using Docker with test containers. But let's maybe take a step back and think about what is integrated test, what does this mean? And it has originally been defined by J.B. Rainsberger, who is a figure from the test-driven development community. And he has this nice definition. I use the term of integrated test to mean any test whose result, pass or fail, depends on the correctness of the implementation of more than one piece of non-trivial behavior, or summarizing it in a more easy way, a test that will pass or fail based on the correctness of another system. Often when we are thinking about integration tests, we are actually talking about integrated tests. And that's why we think about integration tests in such a negative way, maybe. Some examples for integrated tests. If we have to manually set up, like spin up or install any services, a testing environment, for example, I have to have a certain Postgres running with a certain schema, only then my integration test will run correctly. Or when I test against other services in a shared environment. Prime example for this is database host systems, where you have one big integration testing database for the whole department, for all the teams. And yeah, there of course things can happen, and maybe happened to you before, where another team makes some changes, runs tests in parallel, tested some migrations, and then your tests suddenly break, although you didn't change anything. And those kind of tests are pretty nasty, because they make us lose our trust into our test suite, because we never know, did we make actually a mistake, a bug in our code base? Did we make some mistakes when writing our test? Or is it just because the stupid other team again broke the test system? And then at one point we will all the time say like, oh, the other team, it's the other team's fault, they are always failing, we don't have to care, we don't have to investigate. And this is of course a slippery slope. We want to have nice test suites that we can trust. Yeah, and by distinguishing these integrated tests from like nice encapsulated integration tests, we can have kind of two different quality categories of integration tests. And we can say those integration tests that don't have these negative aspects are good or better, and we want to have them, and those are kind of a anti-pattern. We try to avoid them as much as possible. Of course, maybe we can't avoid them 100%. There might be a time where we have to integration test with components of other teams. Then we, by definition, have an integrated test. But it's okay if this is our decision to do it. We just should know about the differences there. Okay, so now which tools we use in our JVM world to write good integration tests that are not integrated tests. And basically we can use all tools we normally use, like our normal Java testing tools. Things like JUnit, like Spock. I'm a Spock fan, it's another testing framework. We can do the tests with Groovy, with Java. It doesn't really matter. Maybe the differentiating factor here is that we try to leverage containers by using Docker, and especially by using test containers as a way to interact with Docker. So sometimes when I give the talk, like people don't have that much experience of Docker yet, and I should give a small intro, but I'm not sure. Should I assume everyone roughly knows what is Docker? Yeah. So who knows Docker? Everyone nowadays, nearly everyone. So to those like who didn't raise their hand yet, for the purpose of what we're showing, you can think of it as a very lightweight virtual machine. It's very wrong to make this comparison. It's not a virtual machine, but it kind of behaves like this in certain ways. So yeah, just think of it as a way to run applications in a nice isolated fashion. All right, and now why we want to combine those containers, those Docker stuff, with our normal Java testing tools to allow us an easy setup of our development environment, and ideally to be able to describe this development and testing environment and as part of our code, as part of our source code, which allows us to run the same kind of tests with the same environment everywhere, like on every machine, but also in every environment, like on the CI server and so on. And yeah, nicer onboarding experience by avoiding that users have to install a lot of external software by hand. But of course now we have to install Docker, so one death we have to die. And yes, how do we combine now Docker and containers with Java? Yes, their test containers comes into play. What is test containers? We may start by looking at a source code example of test containers, of the simplest way to interact with it. And at its core, it's an object-oriented API for instrumenting Docker containers, mostly for testing use cases. And here we see we initialize a generic container. We can just specify any image we want. So this is an image from the Docker Hub, a Redis image, but it could also be an image from our own registry by just specifying the whole image URL. And then we have a builder-like Fluent API to configure this container instance. Here we say, okay, we want to interact with this port of the container later. And yeah, then we just have methods like start, stop to control the lifecycle of the container. And that's basically it. The nice thing here, when we call redis.start, this is different than calling a docker run command, because it will actually wait that the application inside the container is running. If we look at a maybe example, when I do docker run Postgres, so when I run this command, it basically returns in a second or very quickly, because it returns once the container has been created. But having a container created is different from the application inside the container running. So therefore you, especially when you do this by hand with bash or whatever, you like start to engage in certain race conditions where you have to wait for the application to be running. You have to start polling a port or whatever until it starts up. So if we look at the logs of the Postgres here, okay, we see like a lot of stuff is happening when it starts up. It's bootstrapping some tables and so on. So it can take maybe a second or whatever. And depending on your tests and then on your system, you actually want your external components against which you are testing to be ready, to be usable for your system under test. And therefore, test containers takes care of this. Test containers has different strategies that allow test containers to check when the application is actually ready to interact with. And this means this redis.start is blocking until the application becomes available. Alright, a little bit more meta information about the project. It has first been started or first released in 2015 by Richard North, who was living in Japan back then. It's 100% open source, it's MIT licensed. It will stay 100% open source for any foreseeable future I can see. Nothing else planned. We have much more than 65 releases now, 149 contributors. Certain companies are contributing also. I would say an active community. 3 core maintainers. It's Richard North. Then we have Sergey Egorov, who is currently working at Pivotal in the Reactor team, and I joined as the last person. And the core project is a Java implementation, but we have also like forks or re-implementation in other languages. They don't share any code base. They just share the philosophy or the concepts. So the maturity of the other language implementations might differ from the Java one. We 3 are working on the Java ones, but I heard from other people like using the Python one, for example, extensively. Just like be prepared that the feature set is less than the Java one. The Scala wrapper has the same feature set in the Java one because it's just a wrapper. Yeah. The Go one has, for example, been featured by Docker on a blog post once. Yeah, but it's also less feature rich than the Java version. Yeah, I just created this today because it was cool to see that we have much over 3,000 stars now. So yes, growing popularity. Yeah, for a Java project it's pretty okay, I think, over 3,000 stars. For a JavaScript project this would be like nothing probably. Yeah, so then general capabilities or features we bring. Generic Docker container support, that's what we saw in this small example. You can specify any image you want and it will work normally. And in addition we have support for certain special images, special containers that bring you a little bit more comfort, a little bit syntactic sugar, for example for databases, like most relational databases and also a lot of NoSQL databases we support with special classes, and then things like those waiting strategies are already implemented, like finding out if the container, if the application is live. Or for Kafka we have an implementation, and yeah, these bring you a bit more comfort, like having APIs for getting directly JDBC URL out of there and so on. AWS local stack support, Docker Compose is supported, so if you are already using Docker Compose for testing or development in your project, you can just point test containers to a Docker Compose file and then we'll instrument those containers using Docker Compose. Selenium support is pretty nice, so you can use this to start a browser in a container, kind of headless, but not really. It's using a virtual frame buffer to render anything, so everything is still rendered by a real browser, but it's just running headless on your machine. But still you can do cool things like record videos and so on. We will see this in an example. And a little bit newer feature is for chaos testing. We support Toxi proxy. That's pretty cool. You can put this as a proxy between your services and then configure things like drop packages and so on to do certain resilience scenario testing or chaos testing scenarios. All right. Then, yeah, support for dynamic port binding and API. For getting the actual port, this is, if we look back at this example, if we check what this does. So what I wanted to tell you is about this expose port stuff. So normally if you would expose a fixed if you would expose a fixed port, like say, okay, I want to test against the Postgres database, it's running normally 5439. So if I would tell Docker to map this port like this to the container, like always expose this port so I can hard code it in my test, in my in my application, like doing basically this. 5432 5432. Okay, if I would run it like this. Okay, and Docker PS. Then I see, okay, my Postgres is now reachable, localhost 5432. This is kind of nice because I can hardcode everything. But now I already created a scenario for an integrated test. Because if I start a container like this and the port is already used for whatever reason, because something else is running, because I'm starting to parallelize my test, stuff will fail. So instead, what we are doing in test containers, we're not mapping the port, we're just publishing it, like when you do this in Docker. Okay, and now what happens, it will automatically bind it to a free ephemeral Unix port. Like ephemeral ports are the ones over 30,000, so it will always get a free port there, no problems there. But okay, now how do I get the actual port? Because now I have to inject the actual port, the container is reachable into my application. I have then an API in test containers to query this, like basically get first map port. All right.
Why do you have to map it at all? So you can always access the container directly.
How? So the Java application I'm testing is not running in a container, and actually we are not knowing if the Docker engine is running on my host machine. Yeah. And also, especially when you think about like Docker for Mac, Docker for Windows, since there it's running also in a virtual machine, I don't think if you can do it there. So it gets a bit more messy, yeah.
What about Linux?
Yeah, Linux has some more capabilities. All right. Cool, yes, so, yes, wait strategies, I already told you about these, so like checking that the application is available. Easiest one is checking that TCP port is giving a correct like answer, is answering, but also more sophisticated stuff is possible, like seeing that you get a certain HTTP response, or checking that you can do a JDBC query. And Testcontainers works plug and play for basically all kinds of Docker environments. So the way the Docker command would interact with a daemon wherever it is running, like remotely or locally or in Docker for Mac or Docker for Windows, Testcontainers works out of the box the same, so you don't have to configure anything. Not even on Windows anymore. Yeah, so yes, works on all platforms. Windows now even with support for named pipes. Yeah. Yes. So is anyone here using Docker on Windows? Yeah. So you maybe remember, like some time ago, when you wanted certain tools to interact with the Docker for Windows, in the configuration you had to say expose daemon using TCP, because some tools only interact with Docker over the Unix socket. So they think about a Unix socket, which you can use for like with this TCP connection. But on Windows you have a named pipe, which works a little bit like a Unix socket, but also a little bit different. So most tools didn't work at first. Yeah. But Testcontainers now works, named pipe support. You don't have to make this checkbox. NDK 12 compatible, probably also 13 compatible. I couldn't check this today. And yeah, we always try to also build in our CI against OpenJDK early access version to make sure we don't break anything. We are supporting all major CI systems, so whatever you're running, normally it works. If you are running your CI in interesting sounds. If you're running your CI already in Docker, then things get sometimes a bit more complicated, but mostly it's solvable. Yeah, some of the users we have, big projects using it nowadays, like Spring, for example. Spring Data uses this for testing the Spring Data, yeah, different technologies like MySQL integration, Cassandra, whatever. In addition to the direct API, we also have some integrations in test frameworks. Here we see the JUnit 4 integration that's kind of built into test containers, so you can use those containers as JUnit rules, class rule or a normal rule, and then the life cycle of the container will be bound to the rule life cycle, with class rule being started before the class and stopped afterwards, and with rule between every test. And of course this is sometimes expensive, so you have to keep this in mind. The Spock extension we have, there you annotate a class with test containers, and then all fields in your tests that are containers are automatically managed by the extension. And JUnit Jupyter looks pretty similar, so you activate the extension by annotating the class with test containers, and then you annotate all the containers you want to be managed by the extension. Yes, and here we see, for example, one of those special syntactic sugar methods you get from using a specialized container like MySQL container. You already can get the JDBC URL and inject it into your test. Yes, so, but it's absolutely not necessary to use those test framework integrations. It's totally fine to just call by hand the start-stop methods, and often it's even better because it gives you some more flexibility about the life cycle. Alright, and now we have a small demo. Okay, that's all, and then you're good to go. So it works like a normal Java library. Okay, we have here a very simple application, very useless application, like a bookshop or whatever. So also no framework, it's just Java code. We have here a book entity, DTO something, so just two fields, name and author. And we have a self-coded book repository that uses Java SQL connection to interact with a JDBC database just by doing SQL queries here by hand. And this is the production code. This is not really interesting for us. We will look at the tests, that's what it's about. But we have methods like saving books, counting, and searching or whatever. And yeah, then we have another simple class that can send notifications into a Kafka topic. Yeah, so it just sends a string into a Kafka. So that's all what we have here, but we want to now integration test this. And now we check the tests. And I have to check if the JUnit 5 is activated. Yes. So we check first the book repository test. And here we are using the JUnit integration for test containers, and this is a special Postgres container module, and as I said, this also already does this waiting strategy for you, a Postgres specific waiting strategy, and it gives you methods like get JDBC URL, get username. And here we have some tests. We check empty repository is empty, there is a book in a repository after saving it, and having multiple books, we can search for certain books given an author name. All right, and since we are saying here just add container, and here before each, this means we are using a new database for every test. So it's a bit expensive now, this test. Like really every time we will set up from a new Postgres database instance. Okay, now I'm running this. Okay, we see here some logs with a whale. This is always the logs from test containers. First test passed. Second test passed. Okay, so yes, 14 seconds. It's of course, one could say this is like a little bit slow, like if you compare it to a real unit test, if you compare it to testing an H2 database. If you keep in mind that every time you're using a completely fresh Postgres database instance, then it's already okay, the time. Yeah. So you have to think, is it a trade-off I want to make? Like, does it make sense to invest here this time to start up this new infrastructure every time? And of course, there are ways to improve this, because so why we are using a new database every time? This is like the cheapest or most stupid way to avoid test pollution. Like if we have a new database for every test method, we are pretty sure that there will be no test pollution. If I have more sophisticated ways of taking care of test pollution, then I don't have to create a new database every time. Then I can do something like, let's use this pattern where we are using, where we are basically using the same container for the whole method. Then we make this static. And now, instead of solving test pollution on the infrastructure level, we're doing it on the logical level, and by just doing flyway clean. So flyway is just a tool for doing database migrations, and if I call here flyway clean, it just deletes all data from all the tables. So now we are just creating an empty schema basically every time, instead of creating a new database every time. Let's see how the time changes. So before we had 14 seconds, now we have 500 milliseconds. And that's not perfect, but I think we can live with this. And if we have some time, I'll show you even another new feature that we have as an alpha version that can even improve this time, probably.
How is it possible? The startup of Postgres, I think it took more in the previous tests.
No, I don't think so. I don't think so. Why you think it took more?
Like, why did it take 5 seconds for each test the last time?
Because also it's stopping the containers in between in the other case. Maybe this is the reason. So we can, or maybe it was compiling something, we can just change again. So here as you see, like it takes, the first start takes 360 milliseconds, which is the first run. That, yeah. So we undo, oopsie. This is actually a good question. Maybe there's also something off with the measuring from JUnit and IntelliJ here, because yes, you're right, it takes roughly 5 seconds to start it.
I think the problem is that IntelliJ doesn't measure the time of the class initialization.
Exactly.
And this is where the container starts.
Yeah, I agree on this. So probably what we are what we are getting when we change again to this here. So this was 15 seconds, and if we would measure by hand, we would probably now get something like 6 seconds or so on. That would be the more correct measurement, I assume. Oh, actually, I'm unsure. It's extremely fast. I don't know. I don't know.
You see that it was just starting for 5 seconds, and then it all was fast after that.
Yeah. Yes. You're right. So.
5 seconds.
Yeah. Probably we don't see. So if we see here, it's getting started. This was 33 seconds, and yes, 33 seconds, and here we see 38 seconds, Flyway is kicking in. So you're right, like 5 seconds we don't see, IntelliJ is doing something, it's not measuring it, and then, okay. Still it is faster than the other approach. But yeah, a good observation. Yeah. I don't try to trick anyone. All right, and now we see the example for Kafka. Similar approach. Now we use a special Kafka container, and again JUnit integration, and then we just send some notifications, send some messages into the Kafka, and then we poll it to see if it received them. And this will boot up a Kafka from scratch, including a zookeeper, like a one-node cluster, basically. Yep. All right. So, and now we get measured by IntelliJ 8 seconds. Okay. Which is, I think, is okay if you think that you are starting a Kafka here for yourself, a new Kafka cluster. I know many people that were before using the embedded Kafka from. I think it's from Spring Kafka, and they had different kind of problems, and they got better results and more comparable results to production with this approach. All right, so these are examples like just with vanilla Java how to do it. You can of course also do it in the test frameworks of your liking, in the application frameworks of your liking. I have some examples. We don't have really time to dig into here about how to do it in Spring Boot. So in Spring Boot, the interesting thing is that you have to, if you're using Spring Boot test, you have to make sure that those dynamic URLs of the dynamic port are set before the Spring context is initialized. So therefore you normally can't use this JUnit-like integration, because they will kick in after Spring Boot test executed the application context. So one way to do it is have this abstract base class and have a static class initializer block where you do all those stuff for setting up the containers, and then just setting properties on the JVM, and then when Spring initializes the application context, it will take the correct ones. And here we even see another usage pattern of test containers, which we recommend for faster test use, and we call the Singleton container pattern. And it's really like making sure you are using the same container for all your tests, and one of the easiest way to do this is have the static initializer block where you are just starting the containers, and that's it, and then you don't take care of them anymore. Now some of you might ask, okay, but what's happening now? How are they then killed or cleaned, or do I get more and more containers every time? Luckily you won't, because test containers has a helper container it's using every time. Let's run this to see what's happening. Hope it works. We do a watch Docker PS. Yeah, some stuff going on. Okay, so here's this Reusable container. This is a sidecar helper container, test containers is starting, and this takes care of deleting resources. Oh, something failed, I don't know. But in general this takes care of, now everything is gone. This takes care of deleting the resources after they're not needed anymore, meaning as a fallback when the JVM exits. So the way test containers is currently built for the normal use cases is that it will remove all test containers managed resources once the JVM exits. Yes. All right. Okay. Just trying to give you some high-level overview about all those kind of features. If you're interested to dig deeper, just come to me afterwards, ask any questions you want. We also have support for Docker Compose. We are now going to see how to test like end-to-end test some small microservice application. We are using the example voting app from DockerCon some years ago. These are the 5 microservices we are going to test. Now the cool thing is that these are written in languages that are not Java, so you can also use test containers for managing and testing an environment that runs different languages as long as you are having Docker images for them. And yeah, this is a compose file. We will just check what the application does. I don't know why this test failed, but we don't care for now. Docker compose up. Let's see if this works. So I had some pain with this last night because the Node.js installation broke inside the container. All right, that's the voting application, so you can vote between 2 things. Then we vote the correct choice, and then we can see the result now. And now we want to do a UI test of this code, of this application. I stop the compose again. Now see the test application. So this is now a Groovy test, a Groovy JEP test. JEP is a Groovy DSL framework or DSL to instrument and write Selenium tests, but we will not dig into this here in detail. The core idea is about how to use test containers. So we have this Docker Compose container. Here you can just specify the compose file you want to use, and then it just instruments all those things. With local compose true means that it will use Docker Compose you have installed. If you are not setting this, it will create a proxy compose container and mount the file in there. It's also cool, but in certain environments it's a bit can be error prone. And then we are using another specialized container here, browser WebDriver container. This is a container containing a browser and a WebDriver, Selenium WebDriver. Here, by specifying the capability, we are implicitly configuring which browser we will get. So here we want Chrome. And then this is a cool feature. We say with recording mode means we will get a video recording of the test afterwards. Okay, and yeah, here's some setup stuff. And then these are the actual tests. These are Spock tests using JEP for the Selenium interactions, so kind of high level, and they will run in the order they are specified here. So first we will go onto the vote website. We will see that we have 2 choices. We'll go on the result website, see 50-50 vote result, and then we will go on the vote again, like click, like vote, and then we are seeing that it changed to 100%. If there are any experienced Selenium developers here, they will of course kill me for having the sleeps everywhere, so this is super dirty for UI code, but yeah, for this small example it works. In reality you need to do, of course, better weighting checks. Alright, now it's running. We already see like many containers have started here. Okay, and already a lot of them have passed. Actually, all of them have passed. And now if we check this build, test result, yes, we get those video files. And as you see, I've run this test many, many times. That's why I have so many video files. We get the last one. All right, and this is a recording of the test we just executed here. And yeah, since I fixed the repository this morning, if you are like cloning this from GitHub and you're running it on your system, if you have Docker installed, it should directly work without having to configure any web drivers, any browser stuff, anything. And you could run it the same way, just on a server somewhere. So I have here a server in an Oracle Cloud. Okay. Right. Okay, and this is now like a server without X server, without anything installed, and it runs the test the same way, since we're using Docker and everything is rendered in this virtual frame buffer. Alright, so yeah, it now of course takes some time to start everything and so on, but yeah, it should work in the end. Now we see the cute Docker icon. Alright. Yes, alright. So, I try to wrap up quickly because there's not that much time left, but as I said, if you have any more questions, maybe specific to your projects, just feel free to ask me after the talk. I will be here the whole day. This is something, I will share the slides, you can check out. It's a very cool approach by Sergey, one of the other maintainers. This is how you can write basically an application class file that uses test containers to set up your development environment. So instead of running a Docker Compose and then executing your Spring Boot application to do your interactive developing or testing, you can also do everything programmatically. Yeah. CI inside containers, like just quickly speaking, there are different ways to do it, and you have to know how your CI is set up. Either Docker in Docker or Docker wormhole pattern. If in doubt, ask your CI administrators. But it's always possible, or 99.9% it's possible. All right. So one thing we are like kind of excited to show and develop and go on doing is a new feature. We call it reusable containers, because we want to improve the cycle time of developers, especially when having this kind of TDD cycle approaches. And therefore we are working on this new feature where the containers live longer than the JVM. So this is not for having those clean testing environments, it's for your fast TDD loops to be able to quickly make changes to a SQL query, run the test again without having to start everything, even if the JVM exited. And it's currently usable. If I would have more time, I would show how to do it, but yeah, basically it's not really documented yet. You have to check in the pull request to see how it's activatable. You have to specify this flag in the property, yeah, and then it works for some containers. For example, for database containers it already works. For the Kafka container it already works. Yes. All right. Much things in the future. If we ever find the time to work on them, we are planning to release Testcontainers 2.0 that will remove the Docker instrumentation code from the actual test framework code to give you a library. Maybe it will be called Container Core or something that is just an object-oriented abstraction over Docker, because we currently don't have this in the Java ecosystem. Docker Java, which we are using, is just a one-to-one translation of the Docker REST API. It's not object-oriented. Yeah, and some other things we are always getting asked about and we are always thinking about, but we don't know when we will have time to support them or develop them, is support for Windows container on Windows. Since we are not having a strong Windows person in our team, this is not a high priority for us. But maybe this will work now if hybrid Docker engine mode is supported on Windows now. I don't know this. If anyone knows about this, then maybe it already works. We just have to enable it. Support for orchestrators, we get asked this all the time, and maybe slowly we are realizing this might be a useful feature. Docker Swarm probably not anymore because it's dead, but people want Kubernetes support for testing very big environments or whatever. So I'm not a Kubernetes expert, so I don't know why you need Kubernetes support for this library, but if someone has an idea, talk to me about this, or if you're a Kubernetes expert, feel free to maybe join us on this effort. And yeah, another thing we often get asked about is support for other container engines. I think this could be happen in the future. We will try to make the implementation of test containers more configurable, that you can have different container engines, but they don't have feature parity with Docker yet, especially considering things like networks and so on. So we were not that invested to try this out yet. And also some people say like, oh, just use Podman, they have the same CLI, just make a link to it. But we are not interacting with Docker over CLI, we are interacting with the REST API of the Docker daemon. So for this to work, you need to check this Podman proxy stuff, whatever. Maybe someone from Red Hat will develop this one day. Okay, and the last point has something to do with test containers, but if we get a support in IDEs or Gradle or whatever that allows us to run our build already in a container, this would be pretty nice, because then we could from our tests already use Docker features such as Docker networking, and then we don't need to do those port mappings anymore. That would be cool. Okay, here links to the stuff. I will also publish the slides on Twitter, I think. Thank you very much, and enjoy the rest of the conference.